Hey guys, here it is, Unit 6 confidence interval. So you might be thinking, holy moly, there is a bunch of stuff on this piece of paper. But I want to break it down to anything related to confidence intervals. So when they say, please create a confidence interval, you know you're grabbing this cheat sheet. If it says the word interval, you're grabbing this cheat sheet, right? So on any given question, you're never going to use the whole cheat sheet. You're going to use this part of the cheat sheet or this part of the cheat sheet or this part of the cheat sheet or this part of the cheat sheet. So what I mean by that is the reason why there's so much information on here is chances are they'll ask you one of these four things on the test Friday, but not all four. One of the four would be on there. Okay, so it's merely a reference sheet. So I'm going to walk you through. They might ask you a yes or no question. And so I'm going to give an example. Do you support Trump's response to the coronavirus, right? So it's a simple yes or no. So because that's a yes or no, am I quantifying? So that's a means question, right? Am I measuring quantities? In a way, yes, but I'm really just counting up yeses and nos. Okay, so we know that because they ask a yes or no question, that it's a proportion question. Also, you might see the word proportion in the question somewhere along the way. So if you had to answer a proportion question, you want to make sure to include each of these parts in years past. But now, in this current year, they're more than likely going to ask you for each piece separately to help in grading and to also help you answer a free response question that has up to 5 or 6 pieces. So question number 1 will likely have 6 pieces, and question number 2 will likely have 5 pieces to it. So you can see very easily on here that they might pick and choose a question about Trump and whether you support the coronavirus. And they might ask you about the parameter. And then let's say that's part A. And then they might ask you for the formula. So that'd be part B. And they could ask you part C, the conclusion. And then they might jump off of this reference sheet and they might do something else on one of the previous sections, right? So let's get to it. Let's say they asked you a question, a yes or no question, and they asked you to create a 95% confidence interval. Now, we know that they could ask for something else. So it could be 90, 99 and a half, 80. It's a lot of different levels. But generally they ask and they keep it at 95. And the reason for that is that this corresponds to our alpha value of 0.05. So in the same way, we assume that our level or threshold of how rare an occurrence is to get me to think if there's sufficient evidence is 0.05. In the same way, that's why this by default is typically 95, okay? Because 95 plus 5 is 100. All right, so let's get to it. Using the same fact scenario I gave, the parameter is the true proportion of all people in the U.S. that said they support Trump's coronavirus response. So we must say for the parameter, it should be something in present tense, not past tense, and it should be something, whatever is the thing that we asked the yes or no question to. Now for conditions, if they ask for the conditions, or actually more likely now, they'll say which one wasn't met, and then you can talk about it. We're looking for them to say random. So I took a random sample of people from the United States because I'm interested in making an inference about the proportion of people in the United States, right? Now, a 10% condition means, for instance, if they asked 100 people in their sample, we're going to say it's safe to assume that our population of people in the U.S. is greater than 1,000. So notice I just take 10 times n, and that's how I test the condition. And almost always it's safe to assume whatever n is, we just take 10 times n, and usually the population is way bigger than that, so we're safe. Now, large counts. This is our normal condition. And so this formula works and this conclusion works if and only if we have a large count. And the reason for that is that it's not, the distribution would not be approximately normal unless this condition is met. So that's why we're doing it. I've noticed on some of these new formats that they're asking the why question much more often on free response questions. So that's why I'm going to touch on those. All right, so large count just means whatever proportion. So you asked, let's say 100 people, and your sample proportion said 0.32. So I would just take 0.32 times the number of people I asked. So that means I got 32 people said yes, and that's greater than 10. And then if 32 people said yes, if I take 100, 1 minus 32, so that would be 68. Oh, excuse me. 1 minus 32 would be 68. So that would be 68 people said no, and that's bigger than 10. So this condition has been met. Now, here's our formula, which you would have this sheet next to you, so you don't have to memorize it. But this is our test statistic. So again, we said our test statistic was 32, so that would go there, 0.32. Z star is usually 0.196 because we use the infinite value at the bottom of table B, and this is based on your confidence interval. So if your confidence level was 95, that's where I'm getting this number. If your confidence level was, let's say, 98, then instead of 1.96, it goes up to 2.326. So that's why this is a variable, because it is subject to change depending on what your confidence level is. All right, now this is our standard error, and that's it. That's how your calculator calculates it. Now, less likely, they're going to ask you to use your calculator, but I do want to make sure you know how. So this function would be, you go to Home menu, click Confidence Interval, and it's actually the 5th selection, one proportion interval. All right, and last but not least, our conclusion, which is almost guaranteed to be on your test. We're 95% confident, if it's a confidence interval of 95, that the interval from blank to blank captures the true proportion of people in the United States that say they support Trump's coronavirus response. I have to say the true proportion of things that people said yes to in the context of the problem. So let's say that it was 0.3 to 0.34. Now you might be thinking, well, what have I really done? What am I really saying by this? What you're essentially saying, what a confidence interval does is that if we took many, many samples of the same sample size, so my sample size was 100. If we took many, many of these and we created many confidence intervals, we're saying approximately 95 out of 100 of them would capture the truth. And we don't know what the truth is, but we think the truth would be captured somewhere between 0.30 and 0.34 would capture the true proportion of people in the U.S. that said that they support Trump's coronavirus response. Now, I've also jotted this down up top because, again, I've noticed on these tests they're getting into definitions. So the definition of a confidence interval is when we take multiple random samples of the same size from the population, and the confidence interval tells us what proportion of the intervals we could expect to capture the population parameter. So this is exactly what I've said before. So if they've asked me to define what a confidence interval means, I've got this on my piece of paper and I'm ready to use it. Okay? Where else would you, if you don't have this on your piece of paper, but you get stuck on the test, you could go to your glossary. And I would suggest, and I've suggested this a couple times, have your glossary or textbook open nearby. That'd be smart. All right, so how could they change this? They could actually say for a 2 sample. So my example, they're still asking a yes or no, but what if they think that the proportion on the East Coast is different than the West Coast? Well, we would have to define what group 1 is, and we'd have to define which way I'm subtracting. So you got to make sure that you are clear in showing this. But let's say my first group is the true proportion of people that said yes on the East Coast, right? And the second group is the true proportion of people that said yes on the West Coast. Okay. Yes, I support Trump's coronavirus response. We still should state the confidence level, and usually it's 95, or if it's different, make sure you state it. The conditions are exactly the same, but here's something that's a little bit more special. Because I have two groups, I have to make sure that I identify that it's a random sample, that both are a random sample or random assignment. So what happens oftentimes when you have two groups is many times it's an experiment where you shoved people in one group or the other. Or maybe one group is the treatment and the other group is placebo. So you want to make sure that there was random assignment between the two groups if you have that. Okay. Now the next thing is your 10% condition. So as I compare, it looks like the 10% condition is not really different at all. It's just that I have to do it twice. So if I asked 100 people on the East Coast, there needs to be at least 1,000 people on the population of the East Coast, which of course there is, right? Way bigger. And if I asked 120 people on the West Coast, there has to be at least 1,200 people on the West Coast, which of course there is. There's way more than 1,200 people here in St. Pete. All right, now large counts. I'm going to compare, and it looks like it's exactly the same, except I have to do East Coast, and then I got to do West Coast. Same exact test, but I just got to make sure each group fits the bill. All right, now there's my formula. Once again, pretty much the same. But now I have a different calculator test because I have two proportions. I have a proportion from the East Coast and a proportion from the West Coast. So that's where I would go to find this function in my calculator. And now my wording is going to be a little bit different too. I'm going to say we are 95% confident that the interval from blank to blank captures the true difference in proportions of the things. So let's say 32 was on the East Coast and only 30 was on the West Coast. So we got a difference. And let's say we created an interval from 0.01 to 0.03. So what's happening there now is we've figured out that there is a difference, but only like 1 to 3% of a difference between the two coasts. So you might be thinking, can I really say that there is a difference? That's where we get into a follow-up. Okay. So right now, in order to do a follow-up, I could have two scenarios. If I look at this proportion, I notice that both of those are positive numbers. So 0 is not in the interval. So if 0 is not in the interval, I'm going to have to scroll down to the second follow-up if they ask me for a follow-up. So let's do the second follow-up. If 0 isn't in the interval, then we must say we do have sufficient evidence using this level, if it was a 95% confident level, that there is a difference in proportion. We got a difference. It may have been small, but there was a difference if our interval was 0.01 to 0.03. Notice that means that there is more support because the entire interval showed more support on the East Coast than the West Coast. So that is sufficient evidence at the 5% level that there is a difference between the East and West Coast proportion that support Trump's coronavirus response. Now, what if I get a different one? So let's say I got a negative and a negative 0.01 and a positive 0.03. Notice 0 is in the interval. 0 on a number line is between negative numbers and positive numbers. So if this is the case, we must say, since 0 is contained in the interval, it is plausible that there is no difference. Notice the number 0 is within the interval. So it's possible there was no difference using this level. And so there is not convincing evidence that there is a difference. So that's very important, and I think there's a very high chance that this can come up because it lends itself to more pieces to one question, and they're clumping on more pieces to a question. So I think a follow-up there's a high likelihood that you're going to see a follow-up question. So this reference sheet's great for it. Okay. What else? We focused on solving for n. Some of you liked it. Some of you hated it. Many of you figured it out eventually. So I just want to go over that really quickly. A z-star or a t-star is called a critical value. And the bigger these values are, the wider the confidence interval goes. Because anytime you multiply a bigger number by something, the bigger the number gets. So keep in mind that if you have to solve for n, I sketched out a little example question that if there was a confidence interval of 96%, you'd have to go to table B and look up this critical value. And then if they don't tell you the p-value, we should assume just 0.05 because that's the most conservative. All right. Then we use algebra. So if I'm trying to create a confidence interval within 4%, then that's what my margin of error is. And I manipulate the algebra until I get n by itself and round up. Okay. What are some other tips? I'm going to come back to this tip because I want to switch to means. Okay, so if I'm looking at means, everything is pretty much exactly the same except for this condition. So let's look at that really quickly. If you're measuring quantities, right, then you're doing a one sample t-interval for mu. And mu is the true mean of the things that we have measured. Okay, so maybe we're measuring how many hours during the day you're in your house, right? That's something I'm measuring because my answer is 12 hours or 16 hours, right? So that's a number. If I'm going to ask people how many hours they are in their house, I should be random with the sample I pick. I should mention that. And if I talk to 20 people, I should say it's safe to assume that the population I'm interested in making an inference about is at least is greater than 200. Now, we all know that sometimes data is not normal, but if they told me in the problem that data about the number of hours people are in the houses is normal, then I'm good. I move on. Or if I talk to 30 or more people, the central limit theorem states that any sampling distribution taken from a data, whether or not it is approximately normally distributed, would in fact be normal. Therefore, these formulas work and conclusions can be made, and calculations will tell us whether we have sufficient evidence. Last but not least, if you have neither of these, let's say you struck out on those, you can still proceed as long as the raw data you have of your sample shows no strong skews or outliers. But you might have to make a quick sketch. You can't just make the assumption. You have to show us why you think it doesn't have strong skews or outliers. Okay. Now, this calculator function is item number 2. It's called a t-interval. And the same wording, exactly the same. We're 95% confident that the interval from 16 to 23 hours captures the true mean number of hours people are staying in their house. So notice I created an interval in hours, the thing that I am measuring. Next, what if we feel like the people on the East Coast and the West Coast are staying inside differently? Then one could be East Coast, the average amount people in the East Coast. Ooh, I left something off of here. The true mean of the thing we're measuring, the thing we have in group 2. All right, so that would be the true average people are staying in their houses on the East Coast and the true average number of hours people are staying on the West Coast. We must still state the level, and we must show this, the order at which we're subtracting. So same exact thing goes, except now that we have two samples, we may need to make sure that they're independent from one another. And again, 10% condition, do it to both populations. And same thing, check that one of these three things has worked out to both populations. Okay, because we have two, East Coast and West Coast. Now, last but not least, if you get all the way down here, the wording would then be the true difference of means of the number of hours people are staying in their house, East Coast minus West Coast. You got to tell them the order you're subtracting. And once again, you could have a follow-up. So the only difference here is if 0 is in the interval, you're going to start writing this on your paper, but it's not going to be a difference in proportion. It's going to be a difference of means, right? So same exact wording, but it's a difference of means, not a difference of proportions. And if the 0 isn't in the interval, same thing. You would have sufficient evidence that there is a difference in the means between East Coast and West Coast. Not a difference of proportion, but same two steps. Now, a tip in general is that the lower a confidence interval, the narrower it is, and that's because of this critical value. And the higher the confidence interval, the wider, because you must be more confident. So if I have to be more confident, I'm going to broaden my hands to make sure that I'm not going to fail to capture the true mean or the true proportion. Last but not least, this comes up very rarely, but it did come up a couple of times this year. Sometimes you are actually given sigma. Most of the time we're not. So in this instance, you actually would use a z interval instead of a t interval. And these are function 1 and function 3 on your calculator. So function 3, you'd actually be given the true standard deviation of the entire population on both. All right, that's all I had for confidence interval. Best of luck. Talk to you soon.